So here we go again. Today's warm-up, continuing along the same vein of the things that we've been working on. Rational numbers, order of operations, and of course substituting in for those variables. So here we are. This is the expression that we have to substitute into. So the first thing I have is m, which is negative 12, plus j, which is negative 1/2, divided by n, which is 3/5, minus k, which is 5, plus the quantity of j times k, which is negative 1/2, times 5, squared. Okay, so the very first thing that we always work on is the parentheses, what we have in parentheses. Let me start right here with p, parentheses. The only thing that actually is in parentheses is this right here, so that is what we're going to start with. But don't forget, when we have quantities like this that we divide, we treat those as if they're in parentheses as well. So let's again start here with the one that actually is in parentheses. And this is simple enough. We are multiplying, so it's negative 1/2 times 5/1. We need to make sure that they are both in their fraction form. And then we keep the top with the top and the bottom with the bottom. So we've got negative 1 times 5, which is 5, and 2 times 1, which is 2. And of course we know that this whole thing, oh, we forgot the negative. Negative times positive is always a negative. And that whole thing is going to be squared. So that of course means negative 5/2 times negative 5/2. Again, we continue to keep the top with the top and the bottom with the bottom. And that gives us negative 5 times negative 5, of course, is positive 25. And 2 times 2 is 4. So we are, of course, going to head over to the next page and rewrite this in its entirety. So we are going to have negative 12 plus negative 1/2. That is a 2, sorry about that. Divided by 3/5 minus 5 plus 25/4. So we technically have gone through all of our parentheses and now exponents, and we are heading into addition and subtraction. But again, just to remind you, we treat these as if they are in parentheses as well, because we have to do what it says above that division sign and also below that division sign in order to actually do any of that division. So let's start first with that negative 12 plus negative 1/2. Now, just as before, as I've talked about, while we do have rules to follow, and we use that acronym, I love eating apples and avocados, we have to use our heads sometimes too. This one is an addition problem, and the signs are the same. Find the sum. So if we just take this, and we know we've got the absolute values of 12 plus 1/2, which of course is 12 and 1/2, and because they're both negative, this is negative. Again, just reminding us that we can't always just depend on following the steps if it's not going to be as helpful and as logical. So that is my top number here after that parentheses is solved. Now, the other thing we know we have to do is right here. Again, I would say let's make sure that we think before we do any of these things. This is 3/5 minus 5. Stay, change, change, cha-cha-cha. Stay, change, change, cha-cha-cha. We have an addition problem, and the signs are different. Find the difference. So absolute values. I know 5 is larger than 3/5. So when I find their absolute values, I'm actually going to reverse them around. 5 minus 3/5. Now, if what I'm about to talk about is confusing to you, you should, in fact, go back to the acronym and the steps that we were using. However, let's just stop and think about this for a moment. If all you're taking away from a whole number is 3/5, well, how many, if you had one whole and you took away 3/5, you'd have 2/5 left. So since this is not one whole, it's actually 5, we know the one that's going to be broken down kind of separates from it. So it's like 4 plus 1, if you will. Take the 3/5 away from the 1. So I still have my 4 as my whole number. When I take away 3/5 from that whole 1, I'm left with 2/5. So this, of course, is 4 and 2/5. The important thing to remember, though, is I do need to go back to my larger absolute value, which is negative. So this is negative 4 and 2/5. Okay? So I am going to take this answer, and this part, and I'm going to go 1, 2, 3, and we're going to go on to the next page when we put this all together. So here we go. On to the next page. So we've got negative 12 1/2 divided by negative 4 2/5 plus 25/4. So we do now have this division problem. So let's write that in the form that we're used to seeing it, going across with that division symbol. However, as we do that, I'm also going to change each of these mixed numbers into their improper fraction equivalent. So this top number here, we've got 2 times 12 is 24, plus 1 more is negative 25 over 2, divided by, now I've got this negative 4 2/5. 4 times 5 is 20, plus 2 more is 22. I have to keep my negative. And I am going to carry down that plus 25/4. Now I've got division and addition. I know that multiplication and division comes before addition and subtraction, going in order from left to right, but I only have that one division problem. I know that when I divide, I keep the first, flip the second, now we multiply. And you should recall that in one of the previous problems that we've done, that I talked about, it really doesn't matter where that negative sign is. You can keep the negative sign at the top with the numerator, at the bottom with the denominator, or just put it right in the middle where that fraction bar or division symbol sits. So I now know that I need to keep the top with the top and the bottom with the bottom. So negative 25 times negative 5, negative times negative is a positive. 25 times 5 is 125. Bottom with the bottom, 2 times 22 is 44. So we've got 125/44 plus 25/4. So I am, just to give us plenty of room, going to transfer this onto yet another page. So just to rewrite it, I've got 125/44 plus 25/4. And this is now just a simple addition problem. So I'm not going to forget my acronym. I love eating apples and avocados. Clearly I've got lots of room to do this here. So the least common multiple of those denominators, 44 and 4, of course, would be 44. So I need to change both of these. 125 over 44 already is, so I'm just going to rewrite that. 125 over 44 plus some other number over 44. So actually, let me fix this a little bit, because that does go to the wrong place. So it should keep on going over to here. How do I get from 4 to 44? Well, I multiply times 11. So I need to multiply 25 times 11. You should recall that when I talked about the 11 tables during one of the not too long ago previous problems, I talked about any time something is times 11, we just slide it over one to the next. So I've got 25, 25. You see how I stacked those? And then I'm just going to add. So I've got 5, 7, 2. So I know that my numerator is now going to be 275. Now the denominators are the same. I will ignore them. I'm going to add or subtract as usual. In this case, it's addition, 125 plus 275. Well, that's certainly easy. It's a straight up addition problem. 125 plus 275. Well, if I add that 25 to the 275, that gives me 300. I only have 100 more. That gives me 400. And now, of course, I've got my denominator and my numerator. So I'm going to have 400 over 44 as my answer. Clearly, I can't leave that like that. I can't have this tiny little 44 holding up that big, giant 400. So I need to say what number goes into top and bottom. Well, it's fairly obvious, or at least it should be, that they both have the greatest common factor of 4. Divide top and bottom by 4. 400 divided by 4 is 100. 44 divided by 4 is 11. And again, even though I reduced it by dividing the top and bottom by the same number, I still now have this tiny little 11 holding up this big giant 100. Cannot leave it that way. So I have to figure out how many times does 11 go into 100. Well, hopefully you all know that 11 times 9 is 99. So it goes in there 9 times with 1 left over. So our final answer is 9 and 1/11.